Look up at the night sky. It seems peaceful, doesn't it? A silent, majestic clockwork of stars and planets. But this tranquility is an illusion. We are not sitting still. Our planet is hurtling around the sun at over 100,000 kilometers an hour. The sun, in turn, is rocketing through the galaxy at a blistering 800,000 kilometers an hour. And our entire galaxy, the Milky Way, a colossal spiral of 400 billion stars, is itself on a journey. For decades, we thought we understood this journey. We are moving as a result of the Big Bang, an outward expansion from a single point that pushes everything apart. It's a simple, elegant idea, but it's wrong. Or rather, it's incomplete. Because in addition to being pushed, we are also being pulled. Somewhere, out there in the blackness, in a direction we can pinpoint but cannot clearly see, something is reeling us in. We, and everything for hundreds of millions of light years around us, are being dragged through intergalactic space by an unseen gravitational force. We are caught in a cosmic current, flowing at an astonishing 2 million kilometers per hour towards an invisible, titanic object that astronomers have given a suitably ominous name: the Great Attractor. The first hints of this anomaly came not from looking out, but from looking back, all the way back to the dawn of time. I'm talking about the cosmic microwave background radiation, or the CMB. This is the oldest light in the universe, the faint afterglow of the Big Bang. In every direction we look, it's almost perfectly uniform, a baby picture of the cosmos when it was just 380,000 years old. The key word there is almost. When we measure the CMB with incredible precision, we find a curious imbalance. On one side of the sky, the radiation is infinitesimally hotter, its light waves slightly compressed or blue-shifted. On the opposite side, it's infinitesimally cooler, its light waves slightly stretched or redshifted. This pattern, known as the dipole anisotropy, is a cosmic speedometer. It's telling us, unequivocally, that we are moving relative to the rest frame of the entire universe. And the speed it registered was shocking. After subtracting the motion of the Big Bang's expansion, there was still a leftover, or peculiar, velocity of over 600 kilometers per second. Our entire local group of galaxies, including the Milky Way and Andromeda, was being yanked sideways. The question was, by what? In the 1980s, a team of astronomers who would become known as the Seven Samurai set out to answer that question. They undertook a monumental task: to map the motions of not just our local galaxies, but hundreds of elliptical galaxies spread across a vast swath of the sky. By analyzing the light from these distant island universes, they could tell if they were moving towards us or away from us, and how fast. What they found was staggering. It wasn't just our local group that was on the move. Everything was. The Virgo supercluster, the massive conglomeration of galaxies of which we are a tiny, outlying part, was also flowing. In fact, countless galaxies across a region of space more than 300 million light-years in diameter were all streaming in the same general direction, toward a point in the sky behind the constellations of Norma and Centaurus. It was a cosmic watershed, and all the rivers of galaxies were draining into one enormous, unseen basin of gravity. Based on the speed and scale of this flow, the Seven Samurai calculated the mass of the object required to exert such a tremendous pull. The numbers were mind-boggling. It would have to be something with the mass of tens of thousands of Milky Way galaxies, a concentration of matter on a scale previously unimagined, all lurking just 150 million light-years away, a stone's throw in cosmic terms. The Great Attractor was no longer a theory, it was a mathematical necessity. There was just one infuriating problem. When astronomers pointed their telescopes in that direction to see this cosmic monster, they saw almost nothing. The very center of this gravitational anomaly was hidden, perfectly obscured by the densest part of our own galaxy. We were trying to stare at a cosmic secret, but the star-filled, dust-choked plain of the Milky Way was in the way. This region of the sky is so effective at blocking light from the universe beyond that it has its own name: the zone of avoidance. Our own home was blinding us to our destination. For years, the Great Attractor remained a ghost. We could feel its presence, we could measure its pull, but we couldn't see its form. Visible light was useless, blocked by billions of stars and thick clouds of interstellar dust. So astronomers turned to other forms of light, wavelengths that could pierce through the galactic fog. They used X-ray telescopes to look for the hot gas that pools in massive galaxy clusters. They used radio telescopes to map the faint emissions of hydrogen gas, the raw fuel of galaxies. Slowly, painstakingly, a picture began to emerge from behind the veil. There, right where the theory predicted, was a huge supercluster of galaxies known as the Norma Cluster. It was massive, dense, and teeming with old, giant galaxies. This, surely, was it. The Great Attractor was found. But as the data improved, a new problem arose. The Norma Cluster, as immense as it was, wasn't massive enough. When astronomers tallied up all the visible matter, all the stars, gas, and even the inferred dark matter in and around the cluster, it still only accounted for a fraction of the mass needed to explain our incredible velocity. The Great Attractor was real, the Norma Cluster was at its heart, but it wasn't the whole story. The pull was stronger than the sum of its visible parts. The final piece of this grand puzzle lay even further away, on the far side of the Great Attractor itself. By pushing their observations even deeper into the zone of avoidance and beyond, astronomers discovered something even more colossal. Lying some 600 million light-years away is the Shapley supercluster, the single largest concentration of galaxies in our local universe. It is a true cosmic titan, a continent of matter containing the mass of over 10 quadrillion suns. The picture suddenly became clearer and far more complex. We aren't being pulled towards a single point. Instead, we are caught in a vast gravitational valley. The Great Attractor region, centered on the Norma Cluster, isn't the final destination. It's the bottom of a vast basin in the fabric of spacetime, and we, along with thousands of other galaxies, are sliding down into it. But the entire basin itself, the whole Great Attractor region included, is slowly but surely moving, being pulled in turn toward the even more massive Shapley supercluster beyond it. Our motion is the sum of these two colossal forces. A fall into a nearby valley, which itself is sliding down a continental slope toward an even greater gravitational ocean. We are not simply adrift in the expanding aftermath of creation. We are passengers on a galactic river, flowing inexorably toward a destination we can measure but may never truly see.